So last lesson we started looking at continuous probability distributions. We talked about the fact that the area under the curve is what was important for working out the probability. And now we're going to move on to talk about the mean or expected value. So here I've got the formula from when we did discrete. So the mean or expected is the sum of all the values times the probability of that value. And the for continuous, very similar. Our mean, or again we can call it expected x. Now instead of having the sum, we're going to do the integral. And I'm going to put here from infinity to minus infinity. In practical sense, we only have to worry about the upper and lower bounds that are relevant for this question. So if we look at the question below, which I'm about to do, that would be a 0 to 2. And then we're going to do, again, the value times the probability. And in this case, our probability is the function. So all we're doing here is, instead of integrating just the f of x to work out that it's 1 to show that it's a probability distribution, we're putting this x in here to weight it to make it so we get the mean. So if I look at this question here, I want to know my expected or mean of this. Notice again, I've used this 0 elsewhere. That's not the official maths way of doing it, but it's just a quick way. So all I'm really caring about is that this function here has got looks something like that, up to 2, and I want to know what the mean value is for that. So just looking at it, it's got less probability at 0 than it is 2, so I would expect the mean to be towards 2, bit over 1. 1 would be if it was a uniform distribution. So we'll see how we go. So here I want to do the integral between 2 and 0, because those are the values I care about, of x times my function, which is 0.5x. So let's just quickly, that's going to be 0.5x squared. So integrating that, I get 0.5, I add 1 to my power, divide by my new power, between 2 and 0. I put this into my calculator, I'm going to get 0.5 times 2 to the 3 is going to be 8. And then 0.5 times 0 to the 5 is 0. Well, that's 0. So 0.5 times 8 is going to be 4. 4 over 3, or about 1.33. I could say 3 recurring, but then it wouldn't be about. And so that is our mean there. Now, just because we're going to need it later, what if I asked for something like the expected of x squared? We used this last time when we were calculating our variance and thus our standard deviation. We're going to use it again later on to do that. So I'll just talk about it here. Again, here, we're going to take that basic form here, and when we had it in our discrete, we put an x squared there. We're going to do the same. So whatever occurs here, we're going to put instead there. So that's going to equal the integral from infinity to minus infinity of x squared times the probability of x, which in this case is our f of x dx. And that could be other things, but in this case, x squared is probably the most likely thing that we're going to need to put into there.